Thank you enough for making the first session of the last day here. This is tough. These things are marathons. You guys are making it. I know that when I got up this morning, the last thing I wanted to do was come hear me. I've heard this before. It's not that interesting. Was anybody here yesterday for my presentation? Woo, returns. Okay. Hate to tell you, this is nothing like that. This is completely different. This has got a ton of slides. Yesterday, no slides. Just a different point. Yesterday, we talked about this sort of practical manifestation of architecture, this thing. Today, it's talking about why it's important that that thing be correct. And it's really about being correct. I'm an architect. I love being an architect, and there's only one rule to being an architect. You're allowed to do anything you want. You can tell anybody what they should be doing, as long as you're never wrong. The first time you're wrong, everybody you've been telling what to do will turn on you. It's like a pack of wolves. It's ugly. You can do anything you want, just don't be wrong. So it's important to have a way to get to being right. So what I want to talk about today is really about doing great architecture. This is about the activity of it more than the deliverable. And it really comes down to some very simple, obvious things. 4 simple steps. Know what you're going to do, understand, make choices, act on your choices, and then the all-important measure. You do this, you do it over and over and over again. You can't skip the last step because it's the measures allow you to go back and get better. And the idea is nothing happens once. In architecture and software, it's going to happen again. You're going to keep working a piece of software until the last user dies. Right? Nobody's got version 1 shipped, go away, don't do anymore. Oh, wait a minute, we call those phone apps. Yeah, they can get away with that. In the big world where us adults live, sorry if I'm insulting anybody who does phone apps. Actually, they're cool. We love phone apps. Things go for a long time. It takes a long time to get them up and running. It takes a long time to get them right. And you need to be able to accept the steps along the way. So a few years back, you might have heard in the news, there was this plane flying over the Hudson. Something bad happened. Pilot had to land on the water. Remember that story? Kind of apocryphal. Okay, that's an architect. This is somebody who's flying along. They have a nominal course. Things are going okay. Everybody's happy. And something unexpected occurred. The birds flew into, well, all of the engines. This happens in software all the time. You make a plan. We put project plans together. We set up designs. We have committees. We have discussions. And then somewhere along the way, something bad happens. What happens next is the difference between real architects and bad architects. You got to come up with choices, more than one, really fast, right now. And you have to be able to justify those choices based on your understanding of the problem and the context and what you're trying to do. And then the hard part. You have to act on those choices. If you're flying a plane over the water with a whole bunch of passengers and your engines all go out, this happens in a very short period of time. But the trick is, that pilot made a decision. I'm pretty sure he didn't call the tower and say, hey, I really need to have a committee meeting right now because this thing happened and I'm not quite sure which of these possibilities we want to take. No, you're in control. You're a lead position. You make a command decision, and that pilot said, yes, tower, I'm going to land on the water. Not may I, not will I, not can I am going to do this. It's a command decision. Architects have that role. You span all of this activity. You need to be able to step into it and say, yes, we will do this. Sometimes you don't give people choices. They don't make good decisions. But you're never wrong, so make a choice. Stick to it, and let it go. Now, the measuring impact part, if you happen to have been on the plane and you were one of the passengers, I'm going to bet that there was some feedback available, right? That maybe afterwards they had some conversations about their flight experience. And it probably spanned a few things, and people took that feedback and tried to make changes. The same thing happens in architecture. The International Association of Software Architects, ISA, puts on fundamental classes all the time. And the thing that people miss, because it's only called out once in 12 days of class, is that you have to measure your work. For us, that's not just measure the outcome, it's having instrumented it enough up front so we can measure it. It's having identified those measures so we know where to put the instrumentation. It's knowing how much that instrumentation to run so it doesn't impact the product. It's complicated, but if you don't want to be wrong, you got to get that one right. Because that's the thing that will tell you you made a mistake that you can go hurriedly and fix before other people notice you were wrong. So that's great architecture. It's not complicated. But it can be done right and still be done wrong. Anybody here familiar with Conway's Law? Conway? Obscure dude, very smart man. Basically, quotes on the screen, but what it boils down to is the structure of your software is going to match the structure of the organization that built it. In his case, he was talking about a compiler. They were building a compiler. They had 4 teams building the compiler, and surprise, surprise, it became a 4-pass compiler. Because every team had their shot at it, and then they passed it to the next team, right? Size of the structure of the organization impact the structure of the software. Well, welcome to Cohen's corollary. It's the other way around too. Architecture needs to match the organizational communication boundaries. If you have a group of people that all sit in a room and work together all the time, and you build them a federated application, it will be rejected. Not fail. It won't fail technically. It'll be rejected because it won't work the way they want it to work. And that is a kind of failure. The idea is to put tools in the hands of people so they're better off for having them. That is my one and only measure of success. I work with teams, we write software, we put tools in the hands of people who are better off for having them. Not, I delivered on time, they never used it, not my fault. Or, we delivered what they asked for, sorry, what they asked for wasn't what they wanted. No. We're responsible for getting that right. We're responsible for being smarter than they are, for looking farther forward than they do, for understanding that, yes, you are going to patch and rev this thing, even though you never asked me how to do that. That's our job. So the point of today is to make sure we get that right. Now, most conversations with architects and IT people, it's kind of us and them. We talk about the customer, them. IT, us. My team, your team. This conversation's different, and this conversation's got to be ours, together. Everybody involved, customer, user, IT, infrastructure, doesn't matter, we're all one thing. And you've got to be able to do that. So we're going to break this into 2 parts. First part is who are we? The second part is how are we organized? There's a need for introspection here. You have to know who we are. Why are we doing this thing? What is it that moves everybody forward? There's got to be a reason for it, and it's nearly religious. It's deep-seated. It's physical. So, who are we? There's a lot of ways to break this down, and this is, what I'm about to show you is just mine. Does not represent Microsoft, a corporation, subsidiaries, or partners. My lawyers are happy. Okay. So we want, first and foremost, to be able to deliver some kind of value. If anybody is here from Microsoft who's heard me speak internally, they know that I hate the word value because it's so abused by us internally. But externally, I think it's clear enough. We're doing this thing for a reason. The business wants something. They want to produce a thing faster. They want to help their customers faster. They want to get more money. There's some reason behind this. And you can kind of break it down. So this is a book, The Discipline of the Market Leaders. It's actually been around since, I think, the 70s. And it ultimately says you're motivated by one of these 3 things. You're trying to do something innovative, something new, brand new ocean. You're trying to get more time with your customer, a deeper relationship, customer intimacy, or you're basically just trying to deliver better, which may mean more units per minute. It may be that it's bigger things with higher quality, measures under measures here. But you got to pick one of these as your primary. Odds are you won't do one and only one. So to keep things even, and I just realized I didn't start my timer, so I'm going to be late. Oops. Oh well. Somebody will tell me we've got 10 minutes left. Let's use Starbucks as our first example. So Starbucks, Everybody here seen a Starbucks? They're around. I know there's one 2 blocks away from here. It really surprised me. Starbucks got into the coffee business when coffee was not profitable. I'm a pretty old guy. I used to get coffee for literally a quarter. It was at a gas station. By the way, you got gas here, would you like some coffee? It was terrible, disgusting coffee. But you could get coffee almost anywhere, and it was really, really cheap. What it takes to make a cup of coffee is maybe a nickel's worth of material, some water. It's cheap. Starbucks created a market by changing the value of their business. They decided that they weren't going to be particularly innovative. I mean, let's face it. You go in, you order coffee, you get coffee. There's not a lot of innovation there. On the other hand, what they really wanted was to increase the customer intimacy. Starbucks is about that experience in the store. From the moment you walk through the door and hear their music, which they will sell to you, by the way, for a profit, all the way up to the counter and what you order, because for some reason we have to order coffee in 3 languages. Why am I using Italian for the size? And anyway, it kills me. It's like I just want a cup of coffee. So you've got this special engagement that makes you sort of memorize your things. On the other hand, they're really, really good at creating a community. Right? So they have communities of people who go to Starbucks, and they use Starbucks as a place to meet. And it's a place for them. It's not the coffee, it's the experience. That's why they were one of the first to give you Wi-Fi for free. They wanted to draw you in and keep you there. So McDonald's, everybody knows McDonald's, another great U.S. export. I'm ashamed of my people. McDonald's, the chairs are made of plastic and are shaped in a way that is actually designed to not be comfortable. No, seriously, they do this because they want to turn over people. They want you to go, eat, sit, and get out. They want more people in those chairs. That's how they make money. That was their model. Drive people through. Give you your burger fast, get it in your stomach fast, get you out the door fast. And it was an uncomfortable place to be. It was just comfortable enough. Starbucks went the other way. You got couches and cushions and tables. You know, and you could go in, not buy a cup of coffee, and sit there for 5 hours and no one would bother you. It became core to our industry. People built businesses sitting in Starbucks. It's a completely different kind of experience. Operationally, they were very good. So they took advantage of the community they got through this customer intimacy by being operationally sound. Their places are always immaculate. They're clean. They're very quick about moving you through the line because they don't want you in line, they want you in the chairs and then get you back in line. But they don't want you to leave the door. They're very efficient. You go to any Starbucks anywhere and get effectively McDonald's-like service. It's the same taste, the same flavor, the same measures everywhere. And it's completely nominal. In the world of coffee, it's McDonald's. You know, it doesn't suck, but it's Starbucks. Right? And I can say that because Starbucks means a thing to everybody. We've all had that exact same experience, and that was by design for them because they chose this kind of a model. And their architecture supports it. The physical architecture of the plant, the physical architecture of the space, the architecture of the process of handling you, all of that goes together to make this thing. So you need to pick a strategy. What is our strategy? Every organization has one, and this is interesting because either you're part of the team that makes a decision on what this is, or you are a victim to it. But the one thing you cannot do is change it. It is what it is. Unless you happen to be part of senior leadership in your company and you can change this for 15 to 30 years, don't try. Just be honest with yourself. What are we really? Are we a company striving for growth? Is that the thing? Are we a company striving for profit? Which means you will offset quality for money. That's how you make profit all the time. Are we a services company? Do I deliver a thing? Am I bodies for bucks? Or are they simply in a mode of survival? And a lot of companies are. I work for public sector and Microsoft. My customers are government, federal, state, local, city, healthcare, education. I can assure you none of their strategy is profit. None of them work for profit. It's not that they don't care, they're given a fixed amount of money by some other entity. And they have to deal with that. To make an architecture that assumes that the return on the architecture is money would be considered valuable would be a mistake. They're also not part of survival because they're entrenched. You can't take the government away easily. You can vote them in and out. Yeah, I get all that. But, generally speaking, it is what it is. So you've got to find where they are. Well, in this case, government generally is services. How well they serve the citizen is how well the citizen treats them, which keeps them going. It's a little bit of a cycle of life. So you've got to pick an architecture that does that. If I'm going to pick an architecture that has high binding between layers to be built really quickly and allow for high speed processing and little change, I better not be doing it for an organization that's doing services, because services are volatile, they change all the time. And the cost of that change is overhead in an environment where there is no more money. You got to start looking at the impact of all these choices against this background noise. And this is just the first. There's also constraints. Anybody who's put together any architecture or even the design knows that somewhere in your world there is something you cannot move. There is a constraint. Technical constraints are easy. My network is X. I can only get so many servers. I have X amount of memory to work within. These are an area most of us are pretty comfortable with. The rest of them get to be a little bit more iffy. My world is politics. Always. The person who is sponsoring my work, they've got a goal. If it's a military person, maybe they want their next rank. They're in this position for 18 months. The first 6 months are trying to figure it out. The last 6 months are trying to get out. That gives me like 6 months in the middle to do a thing. And after that, I'm not going to get anything done. And you need to understand that political backdrop. Physical constraints are very real. There are countries where I'm not allowed to export the data. I can go to the cloud, but the cloud has to be in a data center in my space. It is a physical constraint. I have put software aboard submarines. Submarines have a very fixed amount of space. As it turns out, they don't get bigger. So you sit down with a design meeting with the Navy in the US, and they say, here's what we want you to do. You have 2U of rack space. And it's in the first conversation, because that is a constraint that will never change. You get 2U, 1 rack, that's where it fits. If you can put 70 drives in there, good for you. If you can put 2 in there, we don't care. Just got to stay in that slot. Physical constraint. Last, of course, is legal. I'll be the first to say this one's a little more fluid than the rest, and you can push the envelope to your level of risk. I tend to take more risks than others, but I've also never gone to jail for it, so far so good. Legal's important, and you need to get it up front. For most people, legal starts with what's my actual contract. Don't exceed your contract. Among other things, you won't get paid. But legal constraints are part of it. And again, if I'm putting together an architecture and I'm taking a reliance on a cloud, and the cloud is an internet connection between me and them, I'm creating an external dependency that's going to cost money. It's going to be politically volatile. It's going to be less reliable than my own infrastructure. And I now have legal agreements to deal with a third party. Architect broke all of these. One pass. I love the cloud. I think this can be done very elegantly, but you need to understand the impact of that choice. It's not as simple as, hey, let's just hoist it on AWS. You can, but then there's fallout. And you've got to have gotten ahead of that, or else you broke rule 1, never be wrong. Next up is structure. This is different than strategy, right? The organization has a structure. And in most organizations, there's the declared structure and the real structure. Okay, you walk in, you say, show me your org chart, if they have one. And it's a thing of beauty. Everybody's got clear reporting lines. We know who's in which divisions. Everything's accounted for. And it's 5.5 years old, and half those people don't exist anymore. And the project lines break all the boundaries. You've got to know where your project and your work fits in this structure. And then you've got to look at that structure and decide what kind is it. Because it immediately maps to architecture. If I have a monarchy, the good old-fashioned pyramid of business, the dude or gal at the top runs everything and can make absolute decision. With no cause, reason, or plausibility, they just say, yes, tomorrow we're going to stop serving coffee at Starbucks and we're going to start selling vegetables. We've got this big people coming through. They should all be healthier. We're going to sell them vegetables. everybody in Starbucks is going to have to shift because it's run as a hierarchy right now. That's their organization. If you build them a system where everybody gets an equal vote, where each division gets to act on their own, and where people can say no, it will be rejected, and it will not work. So doing a distributed system in a feudal hierarchical environment, not going to fly. So if you understand where you are to begin with, you can start eliminating the kinds of architectures that won't work. And what's left over is a couple. And then you can start manipulating those couple to fit more closely to the realities. Again, it's about seeing things for what they are, not what you hope them to be, or more importantly, what they say they are. So why are we organized this way? This is actually an interesting thing for architects to do. You go in, all right, a little bit more background. I do project recovery as my primary activity. Things get broken, people lose a lot of money, they call me up, they say, please make it right. My job's go do that, happy to do it. Well, I go in, and it is a mandate of mine to never be introduced. I'm usually brought in by a CX level somebody, so I've got a badge or clearance, whatever it is, and I just go start sitting in meetings, and I don't say anything. I listen. Architects need to learn first, see first, speak last. Spend some time seeing things for what they really are, make your own notes, think about what you're seeing and how it would impact things, and then start asking questions. And sometime way after that, you can start making statements. But we need to learn first. The reason things are organized in a way tends to fall into 4 basic buckets. And just to be clear, this is not real data. I do not use real data ever in my presentations. You can take that just as a fact, but let me be really clear. I made these numbers up. This is a pie chart, so it would look like a pie chart. Basically, geography, customer, products, and my favorite, random. I guarantee if you think about your customer right now, you can pick one of these drivers. First of all, random covers everything. See, I'm an architect. I'm never wrong. Things that are geographically broken up tend to have, this is the East, Central, or West divisions. Things that are broken up by customer are broken up by service lines, like these are the people who work with the military, and these are people who work with education, these people work with healthcare, and there's specializations around that. Product base, which is what I think most of you would see Microsoft as, and hopefully we are changing that opinion. These are the SQL Server people, these are the Windows OS people, these are the Office 365 people. And that's all true. And it makes a lot of sense. But what you need to do then is take this belief, look at the other stuff, the strategies and so on, and ask yourself, is it being implemented that way? Are they actually sharing things in the back? If I do a system that's specifically for a single geography's instance, is it to be replicated across multiple geographies? Literally, lift and shift, same thing. They're going to be required from some parent source to use that architecture and that solution. Or is it going to be each geography does something unique and different because their customers are different? If it's Asia, Europe, and the US, odds are lift and shift is going to fail. Because what works in Asia does not work in the US. The architectures that go in place, the dependencies you can take, the kind of risks you take, the way things are licensed, very different. And you've got to be able to make that adjustment. I try my best not to talk about maturity, but this particular session is different. Right now, organizations have a level of maturity that you get to be the judge of. I recommend you never tell them. Right? You need to understand it so you can work with it, but don't tell them. It just makes them feel bad. Right? You go to somebody and say, oh my God, you realize you're in chaos. You're CMMI level 1. Everybody Carnegie Mellon people? Okay. Chaos. This is the tradition. You have no repeatable process. You really don't have anything, practices in place. You don't do anything twice. Decisions are made without documentation. Normal. It's okay. But when you're dealing with putting together an architecture for an organization that is, pick 6 of the other future or preceding characteristics, and they're in chaos, your architecture better be able to deal with volatility. All right, so this is different than stratifying an architecture at layers. This is saying what part of this world that I'm dealing with is likely to change. And how am I going to wrap that in things that look like brokers and managers and service buses, or queues? What am I going to put between that change and the rest of it? You've got to put shock absorbers all over the system so that when that change ultimately occurs, it doesn't destroy everything else. Not to get terribly violent, but you got me early in the morning and I've only had one cup of coffee. In the military, in Vietnam, they used to have soldiers walking a row down the road. And they were supposed to be at least 10 steps apart. That's because if somebody stepped on a landmine, it only blew up one guy. If you're all packed together, bad things happen to everybody. And software is the same way. There's a grenade in there somewhere. You're going to build this thing and you're going to put it into production. And there's something you don't know, guaranteed. The question is, how are you going to limit the damage? They come back the next day and say, we're not going to allow any external connectivity. How are you going to function? Do you have the ability to add caching? Can you change storage? Can you change where your identities are coming from? You've got to see the side effect of losing service. Surface is the product. There's a thing called failure mode effects and criticality analysis. It's an arm of engineering. And effectively says what kind of bad thing can happen and how far will that damage spread. There's math. But it starts with looking at your entire architecture and its goals and saying, what if? What if the drive goes out? What if the power supply goes out? What if I lose the rack? What if I lose my data center? What if I lose my network, my router, et cetera? And you go through all of these things and say, what will happen to my stuff? And what am I doing to protect? Not protect it from happening, but being resilient because it happened. Architecture does that in advance of the bad thing. If you wait, they'll just tell you your architecture sucked because it didn't help them. It's part of the design. Having this maturity model underneath it allows you to have that conversation at different levels. If they're in chaos, you say, I understand things are kind of crazy. Let's take some time and talk about the really bad possibilities. You'll feel much better. If they're really mature, then you can say, what we're doing is continuity of operations planning. You probably already have one for your larger organization. I'd like to back my architecture into it because they're going to take care of things like the building being swallowed by an earthquake. You need to worry about your application layer. The network infrastructure is accounted for. That's a very mature environment. It's a very different conversation. Either way, it has to happen while you're developing the architecture, not afterwards, not last. This is like security. You cannot put it off. You've got to do it first, early, and often. So, which architecture fits? I used to use this slide as a test. It started out with all the boxes blank, and they would turn around sort of like Jeopardy. And I would ask people to tell me 3 architectures. But after maybe 15 years of having this and not having almost anybody come up with 3, I stopped doing that. It was just a waste of time. So there's a whole bunch of architectural supertypes. Things that you recognize, things you've heard of, very common underlying architectural types. A fault-tolerant architecture can be mixed with an event-driven architecture, but odds are you're not going to mix centralized and federated. It can be done, but it's complicated. And in the real world, they're not this clean, ever. So Roy Fielding is the guy who actually wrote the HTTP protocol. If you haven't had the chance to read Roy's thesis, I know this is a weird request, go do that. It's amazing. It's about 40 pages, and in the bottom of it is a matrix that basically says, here's a bunch of different architectural constructs, and here's all the quality attributes across the top. It'll say pipe and filter, and that impacts, I don't know, security or performance or scalability or manageability, et cetera. I took his matrix, I've expanded it so that we could use it as QA with customers to figure this out. Give me a bunch of archetypes and look at all the quality attributes. Let's prioritize the attributes for your environment. And given that priority, how do these archetypes play in? If you care about manageability over scalability, if you care about performance over security, it's going to change which of these architectures fits best. And then once you find that, you're going to look at the prior points we've talked about and try to figure out which of them break this thing you just chose. And either one of them's wrong, somebody told you something wrong, or you've got work left to do. Generally speaking, it's the third. There's always work. But knowing which type eliminates the other types. Strategic thinking in software is limited to architects. Everybody else has got to build the thing. This one thing, they're given a job, it's a task. It has an outcome and goals and, if you're lucky, requirements. There's testability, and they're very small and very specific. Strategic thinking happens around all of that. It looks at the context, it looks at the problem, it looks at these kind of concerns, and allows you to make strategic choices. I designed for 30 years. I could be doing my brother's website, but I'm thinking about 30 years. In part, I don't want to go back and do it again, because I'm really lazy. But you need to believe that this thing is going to sustain through change and time and technology changes. Architecture shouldn't be locked in friction, in such a friction-based way that it breaks and shreds every time there's a change. It should break in a well-known way that's safe. All of the architectural types that go into doing this allow you to choose what it's not, and strategy is exactly that. It's not saying what I will do, it's being brave enough to say what I won't do. Eliminate some of these options. Tell your customer you're working with them, making strategic decisions. If we say we will not be event-driven, first of all, you're not Windows. Windows is event-driven. We're going to use some events, but it won't be our primary goal. No, we want to be fault-tolerant. We're looking for resilience and uptime. Maybe it's for medical instrumentation. If you're keeping track of somebody's heart rate, I'm thinking being available trumps everything. You need to be right. You need to be right all the time. It needs to work all the time. And if that means less security, probably not a good trade-off. You know, healthcare, less security? No, we don't want to get rid of that one. Maybe I'm going to be highly fault-tolerant, but instead I'm going to be highly centralized. I'm going to make sure everything's working right on that local device, maybe even on chip, because that's the safe way to provide that architecture. But it would be a crazy way to do a transactional system, because it's got different constraints and different strategic goals. All of those things create boundaries. Boundaries are real and imagined, and the imagined depend on who's imagining. If the person writing your checks is imagining, it's probably true. They get to make those decisions. If you think they're fictitious, you need to push back on them and say, you know, we can cross this line. I'm a safe but aggressive driver. The lines on the street, they're there to guide me. I'm allowed to cross the line. If a baby carriage comes rolling off the curb, I'm allowed to cross the line, not hit the baby carriage. It's okay, it's guidance. It's not mandate. And most of these boundaries are more or less the same way. They're a little fluid. You can mess with them, but you got to do it for the right reason. You got to justify it. Management, fiscal, security, and physical boundaries become real things as you try to implement these architectural decisions prior. So you've made the decision to do a thing away, and you find out that your sponsor has no control over the data center has no expansion room in the SAN, that giant data lake you were going to build for them to do analytics has no place to live. That's a problem. And it's a problem you are not going to solve, because the management that owns that thing is different than the management that owns your thing, and they got to work it out. No amount of architectural magic fixes that. People fix that. Fiscal boundaries are the same way. Somebody comes to you and says, all right, let me back up. The people in the room that love Scrum Masters, we have certified Scrum Masters, a couple of you. I'm going to offend you. I just want to know who I'm offending. Okay, great. Scrum effectively says, we'll put everything on the backlog, and I'll keep working until you run out of money. That's what Scrum does. Right? Everything's possible. Everything goes on the backlog. We keep saying yes. We never say no. We just keep plowing it in there. Take the next thing off the queue, and I keep working until you run out of money. And then we stop because everything's been deliverable, so we can just walk away. Yeah, if you put it in that context, it sounds kind of crazy, but we're doing it all over the world right now. Not a big fan, but there's a fiscal boundary, a reality that says even if you're agile, you need to be able to predict a budget. I need to be able to write a contract for a total not to exceed amount. There are financial boundaries to every work that we do, whether it's an internal project or an external one. there's funding. And architecture can cost a lot or a little. If you're willing to make some compromises, architecture can be darn cheap. You know what? You've got all these old systems running. You have a room full of SQL Server developers. We're going to go client server. Because the skills you have, you won't have to rehire. You won't have to buy new equipment. You won't have to buy new licenses. I'm going to use them. These are the cards we're dealt. I would love to do something more elaborate. But that's how it's going to work. Because the fiscal constraint is real. And you will be loved for doing this. You should also give them a roadmap out if you actually do keep them in client server land, because 1970 was a long time ago. Security boundaries also very real. Again, government guy, security boundaries are everywhere. I've done battlefield systems. This is where the commander stands in the middle of the room. There's all these people around them. They yell out orders. It's very orderly. Security was that there were guys around the tents with guns. The network, the literal physical network in that environment was wide open. Anybody could sit at any keyboard and do anything, and that was a design decision. Because they needed to do that. First of all, in the military, it's possible that something comes flying through the tent, kills one of those guys, and somebody else has to sit down. So they shouldn't have to log back in. They shouldn't have to change. You don't care about their identity. It's some poor dude with a job. That was the philosophy there. It fit for that context and that problem, as extreme as it is, to not have security on the software. The other way around, there are all kinds of agencies that we don't talk about that have nothing but security that is so tight that you cannot reuse software from division to division. You're going to redo it every time, and they're totally okay with that because they won't share. That means architecturally, having a hard boundary around everything becomes important. The threat model becomes one of the top documents you're going to make. Identifying the boundaries and the transitions, identifying the packets and the packet payloads, deciding what's encrypted and what's not, how much time you can put something in flight before you kill it, being able to roll back transactions. These are all security decisions that are very expensive in the architecture. If you're in a messaging system and you have to be able to absolutely delete a message from a system, trust me, I've tried to do this. It took 15 people, 7 months. 7 months to assure that everywhere that thing could have ever possibly landed was checked, confirmed, and erased. And that is a very, very complicated task for one requirement. You've got to be careful. But if security is your concern and that's a security problem they want to solve, no, it will change your architecture. I have to log everything. I have to track everything. I have to know when writes are complete. I have to know who did it. I have to know what machine it landed on. I need hard IP addresses and MAC addresses. And you've got to build all that stuff in before you deploy. Because you can't go in afterwards. We call that a rewrite. Yeah. Links are what fall in between all of these things. So I have organizations and I have strategy and structure as a backplane. I have these pockets of control, boundaries, and then there are the links that bridge things that are separated by their boundaries. Communication, information, and association are the three that I call out, but the really important part is push-pull, firm transient, trusted, and feared. My words, by the way, sorry. Some communication is push or pull, and that's pretty obvious for us. We do it all the time in software, but as an architect, you need to make these decisions because it changes the timing. And in a big, complicated system, timing is everything. When do I get it? How long is it latent? How do I keep it in sync? Am I doing replication? Is it a failover thing? Active-active, active-passive. These are all push-pull decisions. Fixed versus transient is got to do with who owns the other side of the boundary. If I have all known users, but they are transient, you could log in, then you could log in, then you can log in. I have to treat you all differently because of role. Architecturally, I need a backplane that allows me to identify you, figure out what you can or cannot do, assure that you get the right services, and prevent you from doing the wrong things. Changes your architecture. So let's put this into a little bit of a real-ish case. Again, I'm making this up. I have no association with Federal Express except they ship me stuff. And I do not know if this is true except what I've read on the internet, which is as true as you want it to be. All right, so with all that in the back, it does make for a good story because we've all used something like Federal Express, I assume. We've got these categories, their goals, their strategy, their maturity, the constraints, their structure, and their links. Because I'm short on time, we'll just flip them all at once. The goal of Federal Express is operational excellence. You can move a package in any number of ways. You can use different carriers, you can do it yourself, you can hand it to a friend. To choose Federal Express over somebody else is a competitive decision. They have to be operationally excellent. Absolutely, positively get your package overnight. Used to be their motto. Now it's we will absolutely positively get your package eventually. It's okay, they misshipped something to me recently, I should be nicer. They are a services business, and they're built around that interaction with the customer. So that last moment where you go to sign a thing, that piece of software is critical to them. It's critical to the quality of the service, it's critical to their tracking ability, and it's part of their relationship with the customer because they are services based. Everything is a singular transaction. They buy it, you do it, you're done. You buy it again, you do it again, you're done. It's not particularly long running. They are a high maturity environment, there is no doubt about it. They've been doing this long enough. Their processes are mature. They can have very open and honest conversations. We love that. Most of their constraints are technical. Because the reality is they own planes, trains, automobiles. They've got tons of people. They're good at that part. As you start doing architecture for this kind of environment, you are trying to provide technical excellence. They are ultimately a monarchy. As weird as it sounds, if you look at the structure of delivery for Federal Express, they have a hub in Memphis, I think. Everything goes to the hub, and then it routes back out. It's very centralized. Every package always goes through the hub, period. We've got a couple of hubs around the world now, but it's a centralized system with a singular point of control, and if something's going to change, it has to change everywhere. Don't mess with a FedEx label. It's the center of their universe. If you change the barcode on a FedEx package, it will not get there ever. Every system, everything is tied to that little identifier. It is very, very tightly controlled from a high level. They are a monarchy. They are, however, driven by geography because they're moving things from place to place. It is in their very nature to be address-based. And what happens in Asia or Europe or Germany or Africa happens in a way because of that space. It's very geography-driven. Now, they have three kinds of customers. With a little Bing, and I do use Bing, I bet that. I know I'm like the only one in the room, but it's okay. It turns out that they basically have three operational profiles. Business to business, business to customer, and business to operations, their internal operations. They have sets of systems that are different across these three channels. And that's important because each of them has to be handled in a way that meets all the other constraints and doesn't break it, but can be physically pulled apart. Well, Federal Express, as it turns out, as a centralized view, looks like one giant pie, right? It's centralized. It's got all its internal stuff. It's got all of its data. It's all in one place. And basically, boom, we are a centralized architecture. And that is roughly true. As it turns out, all of their internal systems have their own boundaries, their own links, their own connections, and what happens to operational internally doesn't touch business to customer and business to business. It is literally separate systems. So it feels centralized from the outside, but it's not centralized from the inside. Unless you're an employee, then it's centralized for your view, but not the other view. Welcome to the complexity of architecture. Well, centralized boundaries and links are very clear. There's one organization, everything's tied to each other, they own exposure, visibility, risk, etc. All of these things are contained, one unit. Simple. It also brings us to my favorite, the birthday cake. Sorry, this is the N-tier architecture. It looks like a birthday cake to me. You know, it's got layers with icing in between and the candles at the top. Is it just me? I guess it's just me. We put this was the architecture for a decade. Everybody did this. Everything I ever see, every illustration of every architecture looks something like this. You might turn it sideways. That was a big innovation. But while it worked a lot, it doesn't work all the time. And as it turns out, Federal Express very specifically isn't what you think it is. Federal Express turns out to be two architectures in one. Two great tastes that go great together. The people who actually deliver your package, they're not Federal Express employees. I didn't know that. It was a big surprise for me. But as it turns out, they use independent contractors who lease the uniform of the vehicles and the little thing that you sign. separate of the core business of Federal Express. And this changes everything. Now, my centralized architecture, it looks so nice, is more of a federated architecture. Because each of those independent contractors, many of them aren't individuals, they're companies of their own right. They're doing a thing that is very specific, and they don't want Federal Express in it. The piece of their business wants to be part of Federal Express. Everybody plays to some piece of this, but they choose to play together in part, and the rest of it's still isolated. They are a federated environment. Think Star Trek, the Federation. Each of these people have their own boundaries of control. Each of these organizations decide what goes in and out of that particular boundary. It's the thing in the center where they all have to share. And if you're building a piece, you need to know which of these bubbles you're in. Your architecture needs to either support this because it's one of the players, or prevent it because it's trying to hold back parts of it. That means that the boundaries and links change completely too. Mission and choice stays at the central piece. That's where we federate. We agree to do this thing. On the other hand, risk stays out on the sides. Each organization that participates manages its own risk. Your architecture has to comply with this. If you push back and put centralization over this structure, first thing you're going to find out is you've pleased one of many. Now, if the one's the one writing the paychecks, I get it. Sometimes they've got to do that. But generally speaking, when the many get pissed off, the one gets pissed off too. You have to be able to change your architecture in a way that allows for this. So instead of that nice little birthday cake, maybe, one possibility, not the only one, is we go to something like a service bus, where it's event-driven. And all the external participants decide what they put on and take off the bus. They do it in their own sequence, they do it in their own way, but there are standards going on and off that bus, which are part of that agreement in the center. It is a completely different architecture because it is a completely different organizational structure. If you get it right, this grows forever. They add extra parties into the federation, no problem. Put them on the bus, all good. Well, the difference between federated and distributed doesn't look like much. Because really, isn't distributed architecture just federated architecture without agreement? I mean, it's just a bunch of independents floating around the world, right? Yes, and of course, no, because I wouldn't have put up the slide if it was just yes. So on the one hand, distributed organizations look like a singular thing. They can be a single organization which is distributed by business units. From the outside of the business, it looks like one big blob. Building. Everything's in the building. It must be one system. They're all in the same building. But if you look at the politics behind this and the realities of implementation, they are completely disconnected. They happen to belong to the same management and control central, but at the same time, the people doing human resources stuff and the people doing finance run different systems. Frequently, say, SAP and Dynamics AX. They barely talk to each other, and half the work is trying to get them to work better together. This will never work on a service bus. This is definitely not going to work on the birthday cake, the N-tier architecture. You have some hope if you try to do this basically by giving each of them their own data sets, giving each of them their own boundaries of control, and allowing workflow to be the process that moves things around. Workflow and rules are dynamic. They can come to agreement about how I move from HR to finance or back, but those rules can change independently of moving between sales and finance. They can move at a different rate and a different speed. So think about a transmission in a car. Some wheels move very slowly, some wheels move very quickly. You're the thing in between that allows them to mesh up and not grind. Architecture allows you to fix that. Now this, again, differentiates itself from geography. If that would draw. What's wrong? Go forward. All right. Geographically controlled distributed architectures aren't the same thing. Well, they are the same in that there's a headquarters version which has just got little mini-me's all over the place. They're identical stamps of the bigger one with boundaries of control that are smaller. So there's the worldwide, Contoso headquarters and then Contoso Asia. But they have the exact same HR system. They have the exact same finance system. They have the exact same infrastructure, except that the Asia ones can only see data from Asia and the people in Asia, and the Contoso corporate gets to see people everywhere. It becomes a security problem, which means we're going to treat, in this particular case, North, East, and West as individual entities with overlaps to the central, but no discussion between each other. And this is a very, very common version of this. Each of these pieces have to be able to work, but their choices go away. When you're a distributed system, most of the choice comes from somebody else. If you happen to be the corporate guys at the top, you get to set the tone. You're going to say, next year we're going to change our payroll system to a Microsoft payroll system. Please, please. Okay. And everybody below will have to comply. They get a timeline. They don't get an option. You get 2 years to make your change. Different architecture, different constraints. So, if we get it right, it's grand. If we get it wrong, well, let's just say not so grand. A mismatch in these environments is akin to an electronics impedance mismatch. Bad things happen very slowly. The term smoke test is meaningful, right, for everybody, smoke test? It comes from hardware. We used to put stuff together, and you applied power, and then after a few seconds, it got hot, and it burst into smoke. Halt and catch fire is a real thing. You can actually burn boards. The same thing happens with architecture. You're going to sit down and come to agreement. You'll talk about all this backplane stuff. You'll pick an architecture. You'll work with a team. Everything's looking good. You run through test. It works exactly as designed. You put it in production, and then slowly it starts to get warmer. You start to see that if you are instrumented well, you'll see the servers start to get hot. And then after a while, you'll start to hear the help desk getting more calls. And pretty soon you start hearing people talking about starting new projects like yours to do something different because they don't like yours. And after a while, poof, your contract explodes and you're unemployed. It can be pretty ugly, but it's slow. Our job is to get ahead of it. If it's wrong and you take a centralized thing in a federated environment, what you'll have are the people in the federation who want to be independent losing their independence. They will go off and subvert your system by either doing just enough, right? So I've got form fields that are required. They don't want to give me the required data. If you're me, you just put a period in there and move on. I filled out the field. Now I'm responsible for putting all kinds of elaborate logic behind it to catch these guys which are trying to subvert my system. That is a response. The real response is, why are they doing that? They're doing it because organizationally they want independence, and you didn't give it to them. Similarly, distributed versus monarchies. A distributed system means individuals, units of work, are managed by that unit. Which is completely different than a monarchy that's going to come in and say, you got to do it like this. You will do it like this. I'm giving you no options. You've got to be able to drive it. Well, again, rebellion. And in this case, the monarchy will win because the monarchy will squash everybody. Let's skip past the last one because I think I'm at the end of my time. This is my point for all of this. It's not particularly elaborate. We need to see the truth. The truth shall set us free. The truth is not apparent. The truth requires work and research and interaction with the customers and the teams and the lawyers and the finance people. You've got to reach out to everybody and find out what real is. You got to take that thing and use it to build the right parts. You've got to ensure that the solution is working with the truth. When there's friction in this system, it does burst into flames. If you're finding that friction during the conversations, you can resolve it during architecture. If it gets down to design, what you're going to do is drive up costs trying to solve the problems that you failed to catch up front. Architects are responsible. We're supposed to be right all the time. You need to be right predicting 30 years into the future. And it's totally doable. It just requires more actual work. Whether you need a checklist to go through all this stuff or you just decide to do it through random conversations, using everything you learn to establish an image of the truth for that organization at that time, the way they're going to be, against the strategy that they see going forward and the way they make their money and provide value to their people, that's where architecture is absolutely going to win. With that, I think I'm close to time. Yep, 5 minutes. So you can either abandon and leave. Thank you very much for your time, or hang around and I can take some questions. Either way, thank you very much.